Oh, this isn't too loud? There we go. Okay. That's not too loud. We're doing throwback Saturday. Throwback Saturday, I should say. Okay, so I was hacking away at this problem last night, and I feel like I know what to do now. I just have to like execute it, so it felt like something that I could actually stream. Hey boss. Hope you're doing well, dude. Crap. I just got a laptop. I used one and I'm setting it up. I really don't want to do this right now though. Can I skip this? Do I want? Oh my god. Okay. I thought this would take longer. Bobos. Tomorrow, take a moment to do something just for yourself. That's a fantastic fortune. That might be the best fortune that I've seen that thing spit out yet. Ahoy to you too. But yeah, so I bought like a cheap used laptop off eBay, and it just got here like a few hours ago, and so I was just letting it sit there doing its Windows update thing. But it just finished that and wants me to log into a Microsoft account, and I'm trying to figure out what email that's under. I didn't think it would happen like anytime soon, so I started the stream, but I should have just waited. I bet it's this email. Can I do current mailbox? No? That's surprising. Is it this email? Wait. Okay, yeah, it is a Microsoft account, not a Windows account. Okay, it's probably not this email either. There's no way it's this old email. If I still have this attached... Oh, it is this email. I need to change that, dude. Okay. Sorry about this. Next time I'm just going to be remembering what my password is. Oh, they're sending me a code. I'm all twisted up. edgyhighschooler69@hotmail.com. Close. It's edgyhighschool69420@hotmail.com. It's so hard not to read the code they sent me out loud. Takes a lot of willpower. It is edgy, right? I do not want to use my face to sign in. I don't like using my face to sign in to anything. I don't know if I'm weird for that. I need to make a pin? I guess. Okay. I hope there's not... Oh no, you don't get my location. Find my device. I'll live without that. Diagnostic data, no. Inking and typing, no. Personalized offers, definitely not. I know Linux is probably just the answer. Um, Pause. That's what I did. I used my bank pin code. Okay, now it says getting things ready for you. So I assume it's going to take a while. So that means we can actually get back to the math now. Dang it! Nope. Okay. Let's customize your experience. Development, entertainment. Skip. I don't care. Use your phone from your... No. I just want to get to, like, the desktop screen, and then I'm going to put this thing down. Always have access... No, not now. I'm in luck. I've landed a free trial of Microsoft's 365 Personal. Can you guys believe how lucky I am to have landed that? That's crazy. How lucky. I know, I'm jealous. Join Game Pass Premium for only $14.99 a month. Oh, okay. We have desktopage. You can't really see it in the camera. That's all I wanted to do. This baby will get shut off. And then we'll focus on the math. Okay. Oh. That was great content, guys. Thank you for sticking with me through that. Let me know how your laptop sleeps. Mine is abysmal, never goes to sleep. Really? There's settings for that usually. Like it's in the power settings. Well, that's a joke that I'm not catching. There's convert to polar. Oh, we actually are doing a different thing. Windows doesn't respect me. It knows what I do. It knows the skeletons in your closet. Well, that's why, you can't let it sign in with your face. So this might work out to be the same thing as a polar transform, but we're actually using like a Mobius transform. So the domain as we're given it, let me draw that bigger. You have a small circle centered at 1/4 with radius 1/4. And then you have a bigger circle centered at 1/2 with radius 1/2. And the domain we want to solve over is the area between them. So I bet polar would actually work out pretty well for that. But what we've done instead is use a bilinear transformation, aka a Mobius transformation, to transform this domain into just an infinite strip between real part 0 and real part 1. In this problem, the inner circle is being kept at a temperature of 0 degrees Celsius. The outer circle is being kept at 100. And if you are willing to endure a lot of pain, like I did up here, you can prove that once you apply this transform, the small inner circle here gets mapped to the left side, and the bigger outer circle gets mapped to the right side. So our boundary conditions become just a straight line. It's kept at 0 on the left, and then the straight line on the right is kept at 100. This is a much easier problem to solve now. Very importantly, if you take a coordinate transformation like this with Laplace's equation, you get Laplace's equation back out. It is invariant under a bilinear transformation. You can show it. It's a lot of math, though. The only place where it can break down is if the derivative of your transform is 0 at any point. Other than that, you're good though. When I check that, it's never 0 unless you want to plug in infinity. So I'm not sure how I'm going to address that formally, but we shouldn't have to worry about that. So actually, okay, so since it's not conform on infinity, that means we won't be able to say anything about this intersection point right here, because that's where infinity gets mapped to in the transform. Like that point is mapped to infinity in both directions. So we already couldn't say anything about that point though. Like that's okay, because we kind of have conflicting conditions where one circle's at 0, the other circle's at 100. So what's really happening at that point? I don't think we need to worry about that. In this transform, I found it through the basically problem 1. This is problem 2 that I was just explaining. It's kind of a pain to do all this. It's just a bunch of algebra, but you can get there eventually. Okay, so you apply the coordinate transformation to the Laplace equation. You get much nicer. You go from boundary conditions like this to boundary conditions like this, much nicer. I solve it with a Fourier transform because that's just kind of what we've been doing. Important, the Fourier transform is in V because this is the U-axis, that's the V-axis. That was X and Y. We can't do the Fourier transform in U, or at least not in the same way, because U is bounded between 0 and 1, but V is unbounded, so it lends itself much better to Fourier transform. And so then this is pretty regular Fourier transform with Laplace's equation stuff. When you apply the boundary conditions, you basically end up with A of lambda is 50 over sinh lambda. B of lambda is minus 50 over sinh lambda. Plug the conditions into here, and you get this bad boy back out. And then you can notice that you have like these coefficients match, so you can factor them out. And then you get an e to the lambda u minus e to the minus lambda u, which is another sinh, this time of lambda u. You do get an extra factor of 2 if you do that. That's fine. So this is the solution to the PDE after the coordinate transformation, after a Fourier transform. So we need to take the inverse Fourier transform now. And then we'll take the inverse coordinate transform. But I need to actually do this inverse Fourier transform. This is not an easy function to integrate, as it turns out. And I was about to call it lucky, but it's probably just engineered to be this way. This work is really messy, because I started messing around with a bunch of different stuff. But this is where my work ends. I was okay. Really, I kind of want to rewrite it. Inverse Fourier transform of t hat u lambda 1 over 2 pi minus infinity e to the minus I lambda v. It's really annoying because in one of my classes we use k for the Fourier transform variable, and this class we use lambda though. Sinh lambda u sinh lambda d lambda. And that's what we really, 100. That's the integral that we have to contend with here. And as it turns out, the only reason this is going to work out is that u is bounded between 0 and 1. Otherwise, this thing would the integrand would just shoot off to infinity. And actually showing that is kind of not trivial. That's what I was doing with this limit stuff down here. Up here, same thing. My initial idea was to apply Jordan's lemma. But Jordan's, it's actually like do this integral. But the issue is, is that this bad boy has infinitely many singularities at multiples of 2 pi I. And so Jordan's lemma requires that you make a contour that's a semicircle that goes out to infinity. And so we're just going to be what's the word? Surrounding? It's not surrounding. Enclosing infinitely many residues. And maybe there's something that you can figure out with that. But that seems hard to deal with. In some situations, I know it's possible to deal with that because I have dealt with that before. But in that situation, the residues were actually, or like the singularities, they had a maximum height and they actually went closer to the origin. These don't have a maximum height. Actually, okay. If we can't use Jordan's lemma, this problem is going to be harder because we're going to have to use a contour. We're going to have to use a box contour like that. And that's going to be harder to work with. It's probably, it's worth investigating just a little bit more if we can use the circular contour. So they're all going to be simple poles. 2 pi n, 2 pi I n, where n is, we're just want to worry about positive integers for closing above. Really, we're closing from below though, aren't we? Because it's, well, we're gonna have to do both. Because the v could be positive or negative. Okay. Best viewers on streamboo.com. Thank you, Automod, for holding that up. Really, this calculation should be the same regardless of the sign. So for a simple pole, we kind of have this hack of a formula, which is you just take the derivative of the denominator. And then, these are z's. And c equals 2 pi I n. Hacking formulas? Yep, because calculating residues is really annoying if you don't use that one. It's not really a hack. It's not unsound at all. But it's not. It's like it's almost like too easy. Just write out the series true. E to the minus, no. We're gonna have an I times an I. And there's a minus, so that just cancels. 2 pi nv. Cinch. Two pi I n u. U. Hey mouse, what are you knowing about? You're doing PDEs? Nice, me too. So cosh of 2 pi in, we should know that. No, I don't want one for fun mouse. I have way too much homework to do already. And way too many PDs to solve already. Oh, wait. The residues are at pi in. Not just 2 pi n. Right, Zach, yeah. There's a different formula I'm going to use to simplify this. I just need to remember it. It's on this Wikipedia page somewhere. There we go. Nope. Wait. It's like the reverse of this one. There we go. Cosh of a pure complex number is equal to cosine of that number. There we go. So this is cosine of pi n, which is -1. If n is 0, it's +1. So just to the n. Yeah, I initially wrote 2 pi n, but I realized I made a mistake. Sinh has zeros at pi in, not just 2 pi in. So the thing that we get at the end of this is e to the 2 pi nv sinh 2 pi I n u. Yeah, same. Sinh and cosh are actually kind of helpful in certain situations. The horrors of Sech? Oh god. I have not learned that. Arc Sech? That sounds even worse. It has branch cuts. Okay, so the thing that we would need to do here is sum all these babies up. N equals, well, yeah, n equals 0. And I don't know if I believe that this is bounded. It would be a bit queer to see if we brought this to exponentials. I'm going to bet this just doesn't converge, though. In that I should... sinh of a complex number is I sine. Well, is that really necessary? 2 pi I n u minus e to the minus 2 pi I n u over 2. So... The issue is really that, well, wait, V. V, we should know what V is, right? Um, Say I don't remember all of that. Fair enough. The fact that Cinch and Koch blew up for Laplace equation solutions means good things. Uh, I can believe that as long as they're in the, I assume they have to be in the denominator. Can we use Laplace for every DE? I assume they need to be linear. Do they? Probably. And even then, they're only ever going to find certain types of functions as solutions. Okay, I'm going to bet that this series doesn't really converge. I think we could plug something in for V, but it's only going to make the problem worse. So I think we need to go to box contour. Unfortunately. So the contour, oh, we're gonna need two box contours probably. Bruh. Depending on the sign of V. Hey, color cone. So, if we're gonna draw the upper box contour, that's gonna correlate with negative V. Thank you, thank you. It is a great emote. I kind of want to zoom this in, so I want to label things on this contour. Zoom and enhance. Might have bought Repo and Dead by Daylight and played 10 hours of DB. 10 hours of DBD? Holy crap, color cone. Honestly, I played a fair amount of DBD because my friends like it, and I think it's a really stupid game. I don't like it. I hope that you enjoy it, but that game is not for me. So I guess this will be height pi over 2. I guess it's the only measurement we really need. So we're gonna have to prove that basically these three parts of the contour go to 0. Like all the upper parts go to 0. The longest I played DayZ, I think 10 hours. All right, well, we'll say C1, C2, C3, C3PO. Um, and this contour applies for v less than 0. So let's think about the maybe contour on C2 first. Cinch. Ooh. Wait. No, okay, yes. Here. It's not lambda anymore. Look at me. I am the lambda now. Here, z is equal to... What's a good letter that we haven't already used? We've already used x, y, u, and v. I feel like we're running out of letters here. Hey, Famished. Oh, I never even heard of them. Two Door Cinema Club. Yeah, you called it Undercover Martin. Hope we're doing well, Fembox. I also chance to call myself Alpha. That's true. I am the lambda now. Let's go with A. A is a solid number. Things mathematicians say. Wait, no, A is a stupid. I don't want to have an integral in dA. I'm thinking about this way too hard. Apparently, I don't listen to Two Doors Cinema Club. He forgot to call himself Alpha. I really want to explore the music category more. Mojo? Yeah, it is. You're right. I never heard of them either. Because like it was maybe like 2 weeks ago or something. Dr. Gold rated what was her name? Thug Shells, and she has such a good stream. I think I need to get in with the music streamers because it's pretty fun over there. We're gonna say, am I gonna use S? I think that's what's happening. We're gonna use S. We're coming out with the new Nintendo DS. Oh yeah, I have watched a bit of Ari at Home. It's his setup is so crazy. He's literally walking around with just like an entire DJ setup strapped to him. Discover the suit Numb the Greek, the geek, not the Greek. He's just wonderful. That's awesome. Coffee and Trance. Oh, I follow him. I never actually watched though. To the Marias? No, I haven't. Who's are those duck emotes? Oh, I haven't heard of them. Those are pretty good though. All right, we basically have to pray to God or Jesus or someone that we can bound this integral. Hey, Tisser. Um, e to the pi over 2u minus ius. Sinh of something plus something is something, right? Here we go. Where's my snipping tool? My brother was 5. My parents bought him 2 gold push. He named them God and Jesus. That's funny because I I think my sister was a little bit older, maybe around like 8. Our parents got her a turtle and she named it Jesus because it's just what Catholic school kids do. Cinch of the U.S. We're cinching on the USA. Kosh IU pi over 2. Tisser, if you want, you can try me. I kind of have a lot of stuff I need to get done today, but if there's another thing I can do quickly, I can take a look. Kosh cinch IU pi over 2. On the bottom, we have cinch S cosh I pi over 2 plus cosh S cinch I pi over 2. Okay. DS. Nintendo DS. Oh yeah, that name I know. You know your pop, Dessen. Oh god, Tizzer. That's not looking like the type of question that I know how to do. I've hardly done anything with like pivots like that. I'm sorry. Should we make that a cosine of a real number? Oh, Dessen. Well, this is wonderful because I'm being given a homework assignment to test my knowledge on bilinear transforms. And so naturally, I'm being forced to spend most of my time just doing an inverse Fourier transform and not anything to do with actual bilinear transforms. Because this is just a very well-designed homework problem. We're just solving Laplace's equation on an infinite strip. And like I've done the part that they probably really care about. It's a Mobius transform if you know it by that name. Like W equals AZ plus B over C Z plus D. Yeah. If you take that transform and apply it to the coordinate to like Laplace's equation, you get another Laplace's equation back out with your new coordinates. So you can use that to simplify your domain, is the point of this question. But for whatever reason, they've seen fit to give us a very weird integral to evaluate. So that's what I've been spending most of my time on this problem doing, not anything to do with bilinear transforms. Ugh. Okay, cosh of ix is equal to cosine of x. That sounds like something that we should apply to that cosh, because that's just simpler. And so sinh is going to be I sine. Yes. Cosh I pi over 2 is cosine pi over 2. Cosine pi over 2 is 0, right? Oh, I remember this song. I need to put it in my throwback playlist. My throwback playlist is more of like a trash bin, where if I don't know where to put a song, I just put it in that playlist. So it's not really a throwback playlist. It's a mishmash of everything. Yeah, Posner. They're harmonic Mobius transforms? As far as I know, they all are, except if the derivative is 0. Assuming harmonic means that, like, applying them to a Laplace equation gives you another Laplace equation. Okay, so this thing zeroes out. That's nice. This thing becomes I cosh of S. For sure, I'm past my music appreciation class because I appreciate music. Nice. Do you actually have a music appreciation class? That could be a cool class. You can choose it as an elective. Okay. Okay, so now that we simplified this integrand as much as we kind of can, we want to bound it. Is this cosine? This should be cosh. Okay, should I get rid of the imaginary component in the denominator? I don't think it matters. Is there a more elegant way to do this and not with integrals? I would love to not have to do this. I don't know of another way, though. Music appreciation 20 semiclass get filled up pretty quickly, less than 2 days. Oh, probably, yeah. I've taken the first, like, yeah. It's the problem here, and the bilinear transform, or like the result of problem 1 is this bilinear transform here. So we don't technically have to do a Fourier transform to solve this. But that's kind of how we've been doing Laplace's equation. Yeah, Socratic code, I'd rather just not talk about that. I'm sorry. This is a math stream. That's not really relevant. This is a remix. I feel like they made the song worse. There's very few remixes that I actually like. This one's getting skipped because I like the bass song. This is just worse. So I'm gonna want to scroll down and go back to the question soon. So take a screenshot or something if you want to keep a copy of it. Yeah, sure, if you want. You're good? Okay. Um, sort of Socratic code. I'm not super familiar with it, but like everyone who studies math knows like Ramanujan. Um, Constant positive curvature. All right, we're playing it. DJ Dessen. What limit are we taking here? We're letting S. We're letting the magnitude of S go to infinity. Okay. So how do we do this limit? If this thing does converge, the thing that's going to save us is the u's between 0 and 1. Make or recognize a graph just by seeing its equation. Hey, Lucas. It's just a lot of practice, Socratic code, unfortunately. It will, once you do it for long enough, you develop like intuition for how an equation should behave when you graph it. Like you can ask yourself what should happen at important points, like 0, or as you go far off to the right or far off to the left. But really that sense just kind of comes with a lot of practice. The only problem one here is me. The result of problem 1 is the Mobius transform. So 2z minus 1 over z. Actually, yeah, if you want to just well, problem 1 won't actually show the result, but basically the point of this is to map this domain into just a vertical strip here. Am I good at physics? Not really Socratic code. I know a little bit, but not much. And I'm going to scroll down again. Selecting on the Olympiad for second round, I can get 25 out of 30 questions. Okay, I mean, that's not bad already. um... You know what? We can graph this. I think that's worth doing. Um... Quinner, how's it going? Hello, hello. Oh, this is bad. This is not what you want to see. Oh. Why does that happen? It sort of is, Lucas. It's more of a hyperbola. Uh, like this is... Oops, what the hell's happening? So like, this is actually, it looks like a parabola, but it's actually a hyperbola. It's a sum of two exponentials. That's so weird. There's a breakpoint. That's not good. Just playing some games? Nice. I'm doing good too. Got a lot of homework that I'm trying to, like, get through. I'm hoping that I can get enough done that if repo does happen tonight, that I can play for a bit. So far it's not looking so good. I thought I would get through this one problem faster than I have been. One question was like, you have 40 numbers in their products. How many numbers do you have to at least remove so the last digit ends with a 6? What the hell? Yeah, that is weird. Next week, the University Math Olympiad for all of Central and South America will be held. Ooh, that's hype. Is there a movies transform page where I can visualize it? I don't have one. No, I'm sorry, Lucas. Not today, at least. Those are fun questions. The derivation of Euler identity of complex numbers. We can talk about that in a second. Socratic code. Basically, Dustin, the smaller inner circle gets mapped to the left side, and the large outer circle gets mapped to the right side. Oh, Lucas, VIP for 30 days. Very nice. Hey, Gold. Okay, so Socratic code, there's a few ways of getting Euler's identity. I think the most straightforward one is to use series. So Euler's identity is e to the I theta equals cosine theta plus I sine theta. And so I think the most straightforward way of verifying this is to look at the series of each of these. So the series for E is n equals 0 to infinity. It's going to be I theta, whatever's in the exponent, to the n over n factorial. Yeah, hopefully, Quinner. I appreciate you hanging out. Down to 77 credits? Oh, geez. So much Laplace these days? Yeah, Gold. Like, the homework that I'm trying to do is making a Laplace's equation, the domain for it simpler, using a Mobius transform. And so I've done that. Where, like, we go from this, like, circular domain here just to a vertical strip that's easier to work with. But the thing is that there is this really difficult inverse Fourier transform that I've been stuck on for the entire stream, and more from when I was working on it off stream last night. And so I'm just trying to hack away at it. I've got this like box contour that I'm trying to like work through and bound things, but it's not fun so far. Yeah, because if you only can like drop the question in chat and like someone might want to like talk about it, but I can't really do any problem that's like overly long today. Okay, so this is the series for E. The series for cosine of theta it's all the even numbers because cosine is an even function. It's going to be it's going to alternate as well, right? -1 to the n, theta to the 2n plus theta to the 2n over 2n factorial. And then we have I times the series for sine, which is all the odd numbers because it's an odd function. I believe they're the same alternation though. Okay. You think it should be done in a simpler way? If you want to rescue me from doing this inverse Fourier transform, I would welcome that. I don't think there is a way, but that would be great. Okay, so on the left side, I'm going to write out the first like maybe 5 terms. So if n equals 0, we get 1. If n equals 1, we get I theta over 1 factorial. If n equals 2, we get minus theta squared over 2 factorial. If theta equals, or if n equals 3, we get minus I theta cubed over 3 factorial. If n equals 4, nope, not I. Theta to the 4th over 4 factorial. And then we'll do one more for good measure. I theta to the 5th over 5 factorial. And that should be equal to something over here. So first writing out a couple terms from this series. I can't think. It's going to be 1 minus theta squared over 2 factorial plus theta to the 4th over 4 factorial. That's enough for now. Plus, and that's true, Dr. L, yeah. Hope you're doing well. And then when n equals 0 over here, we're gonna have I theta over 1 factorial, if you want to call it that, minus I theta cubed over 3 factorial. We'll do one more. Plus I theta to the 5th over 5 factorial minus da da da. Okay. Now, importantly, these, oops, I did forget one little detail. Plus ... Importantly, these series are convergent. So you can rearrange the terms willy-nilly. And that means we can take this one in front, then this I theta over 1 factorial, that minus theta squared over 2 factorial, that minus I theta cubed over 3 factorial, plus theta to the 4th over 4 factorial, and then plus I theta to the 5th over 5 factorial, and then we'll end it there. And oh look, this matches that exactly. So that's kind of how you can justify Euler's formula. Second time around, intermediate algebra is as smooth as butter. Noish. Slash begin proof. It's true by e to the 2i pi lemma slash n proof true. Take my time with completing 1 page a day, 200 pages, but it's a long course. Okay. It's not bad. See, has a credit code. I hope that helps. Oh, wait. We might be getting saved. Because I was concerned that this thing is not... The limit is only gonna converge when the number was 0.5. I forgot my square root though. Oh, look at that. Nice. We need to show it, but we're on the right track. Orange juice? Yeah, it is. Hope your coffee's good. Let's oh, I'm sorry. This thing down here was not part of the problem. This was just a question from Socratic Code in the YouTube chat. Chocolate croissant for breakfast because it's Sunday? Ah, that sounds amazing. I just got some chocolate croissants. I have them in the freezer. I'm eating hot dog. The fam brought me... Oh, well, we said the fam. I thought you were talking about yourself in the third person. I was like, oh, Famish doesn't usually do that. But no, you mean like your family. Nice. Yeah, I was wondering if I should stream this, and I was more optimistic that I would get through this problem quickly. I think optimism is kind of misplaced now, but I'm making progress at least. Hot chocolate sounds nice. Oh yeah, hot chocolate's great. Okay, so how do we do this limit? I would prefer not to L'Hospitals. That sounds kind of painful. I can... the thing that I'm going to get out of it is that this limit is going to become 0. That's what I just checked in Desmos. And this bounds the integrand from above. So I'm showing that this thing goes... This part of the integral goes to 0. I'm pretty sure I'm right. Because of what I checked in Desmos. I just need to, like, get it on paper. But yeah, so I'm choosing a box contour, and I'm working with the top part of the box right now. I'm going to do the same thing for the sides of the box. And then I have to repeat this over again for the flipped over contour. Because I just really love doing contour integrals, I guess. El cono de color. um, so we could bound this again from above if we bound cosine and sine by 1. Let's make sure that's legit in Desmos, because proof by Desmos. It's my favorite kind of proof. Nice. That's what you want to see. Oh. Oh, that's not... no, that's still... yeah, that's still fine. As long as it's going to 0. That's kind of a... It's like an M. When... That's kind of a funky... It's a, this puts the funk in function. Because it's funky. Okay. It's a funky function. Mm-hmm. That'd be a good, like, math-themed band name. The funky functions. Could I also... I want to bound it above by squaring this, but I'm kind of claiming that it's less than 1, so squaring it would have the opposite effect. I just don't want to deal with taking the derivative of the square root. Oh, you know what we could do? You know what we could do? Let's say that cosh is equal to square root cosh squared. There we go. That's the key. Okay. This is something that we can theoretically work with now. I really... technically the square root is never going to go away here, but I really don't feel like writing it. I'm putting the square root... like, I'm reading the limit inside the square root. And I just don't want to rewrite it every time. I'll put it in green for this one step. That's also cosh 2 US? Oh, using a half angle. Yeah, that's true. I don't know if I want to use that, but that's true. Or something like that. Sin squared US. Cosh squared US. Over cosh. Actually, well, if we do L'Hopital's this, maybe we do want to do the half angle. Ren, yep. Where this is coming, where I'm basically solving Laplace's equation on a weird domain that we simplified using a Mobius transform or bilinear transform. And I'm using Fourier transforms to solve it. And I just got this kind of really annoying inverse transform that is what I'm working through right now. I am taking the limit of the USA. Gamma 70 has this. Let US equal CA. Let it equal NCCA for New California Republic. Oop, I just banged my mic, I'm sorry. Okay, how did I had a limit like this that I was doing last night. How did I do that one? Somewhere in this stupid pile of work. I brought it to exponentials, and then I L'Hopitals'd. Let's not go to... Oh, or Canada. Yeah. Saying US equals Canada, though, that's a little more controversial. I'm not saying that. Someone else is saying that, but I don't agree. Okay. So we might want to use some of these. Do I though? Is it that bad just to deal with exponents? No, let's just deal with exponents, I think. That's a no. Just no. I'm gonna assume that that's a meme, but no. Uh, I'm just gonna delete the messages because I don't know, it's getting a little too real for me there. Um, Not realizing I think it's going to happen, but just realizing people are actually trying to say that, and it's just not cool. To Kosh. Hey, Vossen. Hope you're doing well. Singe S. Now what? We don't get a cancellation. Wait. Oh, these combine forces now, though, right? Yes. Playing Skyrim all day. That does sound like you're doing great. Glad to hear it. Man, I feel like I need to go to exponentials anyway. I wanted to avoid it. Taylor's theorem? Uh, isn't Taylor's theorem... Is that one where you can bound the terms of a Taylor series? Or is there a different Taylor's theorem? The genie done fucked up, got myself 2 beers, about to add 1 extra electron to every atom in the universe? I don't quite know what that means, syntax error, but slay. That's what I say. I really don't want to go to exponentials, but you're going to make me go to exponentials. E to the US minus E to the minus US over 2 E to the US plus E to the minus US over 2. You know it's bad when you have the formulas for Cauchy and Sinch memorized. Like a limited development, you keep enough terms to obtain the bound you care. Oh, okay, fair. Exponentials are good friends with Taylor. Fair. Just even an odd part. Yeah. For reasons it's hard. It's always harder for me to remember it for sine and cosine. But yeah, that is like a good way of checking. Like it should be odd or even. That's how you compute 99% of the tricky limits. Yeah, I'm just always afraid to use series because I don't quite know what they count as allowed for homework still, to be honest. Is this really cinch of 2 times US? Oh, of course it is. Yeah, that makes sense, actually. The Anniversary Edition has all the DLCs and Creation Club content. Noish. Oh, I forgot they did that with Skyrim mods. That was like a really controversial thing, right? Addiction mechanic. Yeah, let's go. Addiction. Yeah, this is hyperbolic sine and cosine. I I kind of prefer to work with them now when they pop up, but in this problem in particular, I think there's no other way than going to the exponentials. Um, hey Jake, I I was like about to write something in the Discord a couple of times. Um, I have a lot of homework like this week and probably over next week too. I wanted to get like enough done that I could like play with you guys for a bit. I don't so far that I don't think that's gonna happen though, unfortunately. Um, yeah, it's getting towards the end of the quarter, so I just have a lot of stuff that's being assigned. So it's probably not gonna happen for me today. I hope you guys have fun though. You have no other math friends? Dang. Well, I can hook you up. Sounds good though. Just study limits and then series legal allowed to use L'Hopital's and series expansion. Nice. Intro to series, still got a course of series to do. Okay. Hey Ved. Yeah, I remember your name. Oh, I just saw you probably pinged me. I wasn't even looking at my Discord. Oh, okay. You got me. I've just been streaming less, but I've still been streaming Ved. I started going to grad school, so I haven't been able to stream as much as I used to. Limit S to infinity 2u. Then when you do that in differential geometry, you get the higher term or like some really complicated expression that depends on the curvature tensor. Oh no. Having 5 homework for the past 1.5 months every week. Oh my god. Oh yeah, I remember you saying that. These are cool only in algebra, not in differential geometry. Exam next Monday on integration. Please, Lord, allow me to go beast mode on these fools. Yeah. So next year, you're gonna unleash some ungodly techniques like that. They're just gonna make you integrate like x cubed plus 2x squared, and you're gonna like go Super Saiyan on it and use like all sorts of like, you can use like a series wouldn't really do much there, but like just do like a contour integral or something, or I don't know. It's funnier in my head. E to the 2s over e to the 2s. Yeah, I'm just I can't do 2us plus 2s in my head apparently. 2su plus 1. There we go. Hey, Skirtle. Hope you're doing well. I wish I could play Repo, but probably not gonna happen for me today. How's software engineering feel in the US? Like, how are job opportunities? I haven't been looking for myself, Ed, but I think they're not as good as they used to be. As far as I know, it's pretty saturated. Yeah, I was syntax, but I was having trouble working out how the exponent should look. Okay, now we're gonna L'Hopitals again. And don't worry, guys, we only have 2 more integrals to bound after this. Okay, are we finally in a place in life where we can evaluate this integral? So we need to remember the only reason that this would possibly work is that u is between 0 and 1. You don't like locally free C infinity module of finite ring. From a calc professor make an exam like this. Evaluate int x dy, leave a big space where x equals square root cinch y over ln y. Oh my god, that's so mean. I've seen oh my god, why can't I remember his name? Black Pen Red Pen. He has some videos on like all-in-one calc final problems. So it's like the integral from a derivative of a function evaluated at a point up to like the sum of some series. Oh my god, I can't. Like 1/2 to the n of some other thing where you have to do like something inside there. And it's like just a bunch of different calc problems in one. L'Hopitals? That's how I was taught to say it, at least. Yeah, that is torture. But honestly, that's not even the worst one that I've seen him do. The worst one that I've seen from him is he actually integrated a square root of tangent. And that's a terrible integral. You can do it with Calc 2 techniques. It just takes so freaking long. And he even had a follow-up video where he took the derivative of the answer he got to prove that it is square root of tangent. Yeah, I forget what the first step is, but there's a U sub that you do that makes that actually possible. If U is less than 1, what happens here? Isn't this bad? Should we divide the 4s? Yeah, we should, I think. Okay, so we have a 2s minus a 4s. There we, yeah, that's going to get us what we always hoped and dreamed of. Yes. Oh wait, we need a, that 4 needs to go there. It's not important, but we should be correct if we're gonna be. That'll be plus 2s minus 4s is minus 2s. So that's gonna become good. Okay, perfect. Okay. My mission is for Zach to dislike integrals and like algebra. That is a hell of a mission, Destin. If you can get him to change his opinion on that. That's an accomplishment. Oh, Zach found a Zach exchange. Nice. Integral of just tangent. Yeah, that one isn't too hard, I don't think. It's relative to the square root of tangent. Favorite Calc 2 technique that pops out of nowhere. Int 1 over 1 plus cosine x. What do you do with that one? Because I know of wire stress subs, and I know of complex variables to do an integral like that. But neither of those are Calc 2 things. By me, the only integral ideal in practice are obtained from characteristic class, and I use calculus to evaluate them. PhD, algebra. Do you like algebra, PhD? I feel like I always hear you talking about like every part of math. Wish you the best. Oh, hey, Papadoria. Yeah. Did you change your name? Do you always have the 6 on the end there? I feel like you were just Papadoria 007. Okay, so because u is between 0 and 1, at least as s goes to positive infinity, this goes to 0. Same with this one here. No, even I realized I'd never seen the 6. Oh. That's weird. That's so random. Some genius somewhere came up. Okay, yeah, so that is the wire stress sub. Which that is just a usage, so I guess you could call that Calc 2. I definitely never learned about it in Calc 2, though. I'll not study fancy new things until I pass quals. If I specialize, I probably go more stats / probability. Enjoy algebra a lot, too. Okay, that's fair, PhD. You're oh my god, Vossen. Salute. Good luck. Well, here's the thing, Dessin. I only proved it for s going to infinity. For s to negative infinity, we technically need to prove that too. I'm just gonna phone it in and say that that's also 0, though. Because I had the absolute value of s, but as soon as I used L'Hopital's, I think that wasn't valid. I really cannot be bothered to deal with that, though. Okay, so what we've just done is prove that this integral on C2 goes to 0. That's what we needed. Now we got to deal with C1 in C3. By symmetry. It is an even function, to be fair. Because Ooh, no, with the E in front, it's no longer even. Never mind. Okay. Well, oh my god, this is so much work. Actually, this was also only for v less than 0. Technically, we would also have to say something about when v is greater than 0 and the contour gets flipped down here, but that's a problem for a different dawn. Sinh is odd, but not when you divide it by another sinh. No, it's still for 2025 dawn to solve. I guess it's just not for dawn of right this instant to solve. That's problems with 2026. It's a good technique. I like it. Okay. The pain that you have to go through when you can't use Jordan's lemma. So here Z is going to be R plus I S. So DZ is IDS. It's the Nintendo DS by Apple now. Because it's IDS. And S is going to go from 0 to I pi over 2. Why am I writing this in green? The IDS would charge you $800 for the second screen? It would. This is very stereotypical math any high school student would imagine about a math grad student. It kind of is, yeah. Yeah. Okay, what's our addition? God, this problem is so fucking long. Okay, sinh it's your sinh. It's not my sinh, it's your sinh. IUS Kosh your sinh IUS. If I get a similar looking limit, I'm just gonna cite the previous result. I'm not doing it again. Sinh R Kosh IS Kosh R sinh IS DS. Is this the longest math problem I've done? That's a good question. This might actually be it. Well, no. There was a previous homework for the same class that was terrible. That I think is still longer than this one. It was about, it wasn't the Hilbert transform, it was about the Rilbert transform. But it had the same thing with using a box contour that just takes so much time to do anything with. Uruguayan cinch? Oh yeah, because you are. Collaborate with homework? We can. I haven't really collaborated much, but a lot of people do. Oh, there is a Discord server for the department, and there's a channel for this class. I've hardly seen people use that one, though. Okay, cosh of ix is just cosine of x. I'm gonna verify that on Wikipedia. Yeah, it does, and that requires me to, like, be outgoing, though, and that's just not gonna happen. I'm glad you understand. Oh, okay, so this is a little bit unlucky. Not unlucky, but or it's not about luck, but um we're not gonna get like in the last integral, this term just went to 0. But now it's not. Oh yeah, Destin, that's definitely true. Okay, so um it's kind of interesting. We're integrating in S, but we're gonna take the limit as R goes to infinity. So actually we kind of need to bring this thing back inside the integral just to be complete. Okay. It's like a pretty good substitute for group work. Yeah, that's true, Dr. L. I've learned a lot just from doing this stream. Yeah, the regular cosines and sines pop out because we had cosh and sinh of complex numbers up here. And so I used those identities up there. Oh my god, I was wondering what cosine of W is, but that's cosine of US. Ugh. Can't read my own handwriting. Hey, GGG, what a username. This is for my applied complex analysis course. Yeah, I'm not enjoying this problem at all right now, but overall it's a pretty cool class. I guess there's not much we do besides take the magnitude. Hopefully Pythagorean theorems save the day. If you had to choose, what do you think is Euler's worst method, formula, idea? That's an interesting question. I don't know if I know enough about his work to really point out a worst one. I could have to bring up his Wikipedia page. Which I can in a minute here. Yeah, you did say I can define worst however I want. So I could just say, like, Euler's formula is the worst. His architecture work? Did he do architecture? Oh. Capit it. He was a geographer and an engineer also, apparently. Euler substitution and integrating? What is an Euler substitution? Yeah, that's always impressed me, Peach Tea. Like, the further back in time you go, the more, like, descriptors people have on the Wikipedia page. Oh. I never learned these. This is annoying. This is a good one, Papadoria. Like, it's helpful, but I would never want to do this. I would do this with, like, ArcSine or something. Oh, but you can only do it with ArcSine if... Well, no, you can... yeah, no, you can still use ArcSine if C isn't 1. You just get a coefficient, right? I don't know. He did work on buckling? Factor out C, yeah. His worst work is as prolific as wire stress substitution. Wait. Oh, it's a stamp. I thought that was money. Euler's critical load? That sounds kind of dirty. Oh, I want to see if I can find something first that I can name that's his worst thing. Then I'll look that up. The Euler macaroni constant. I'm not too huge on that one. Oh, number theory. I'm not a fan of number theory either. Like, I don't care about this. He hates that constant. I don't necessarily have any, like, I guess I don't really know what I have against it. It's just kind of random. I never heard that rumor, Dessen. Oh, interesting. Yeah, this is straight up an engineering problem. I never heard of this, Vossen. That's cool. I think there's some math YouTuber who use the macaroni theorem a lot when doing meme problems. His investment in tulips. When did he do that? Music. Did he make music or... Okay, no, application of mathematical ideas in music. I can't hate on this. Did not receive wide attention was once described as too mathematical for musicians and too musical for mathematicians. Aw, poor guy. Ooh, that's a cool way of measuring someone's work. Number of pages? 30,000 pages. That's a lot of work. I wonder what, like, it'd be homework, I guess, mostly, but like, what would my work amount to? Sounds good, Dr. L. Enjoy cooking. It. I mean, I think I'm quickly coming up on 30,000 just with this one problem. Oh, cool. Euler has been on money. That's sick. Frank? Is that Switzerland? It is, yeah. And Liechtenstein. Can't forget Liechtenstein. That's cool. I guess I'm saying Euler macaroni, but I don't know. It's kind of a hard one. He was born 17 something. Oh. Yeah, that's like if we invested in horse-drawn carriages right now, then when cars, like, you know, got invented 100 years ago already. I don't know if it was 100 years, but like something like that. In the year 3000, $5 bills will have Don's face. I feel like we're not going to have paper money in the year 3000. We may not have money at all in the year 3000, depending on how the world goes. And that could be a utopia type of thing, or that could be like a, you know, end of humanity type of thing. Money, yeah, it's true, Papadoria. Dawn coin. It's my new cryptocurrency. For Monopoly, I would take that too. By the time we'd have an instant growing tree, that would be sick. Gamma coin for factorials. Yeah, in order to mine a gamma coin, you have to compute gamma of like huge numbers. Or wait, do maybe you have to do the reverse. You're given a huge number, you have to compute what it's gamma of. Did I win? I won the first round. I'm currently on round 2. I've done the limit. I keep bumping my mic. I am sorry. I hope that's not too loud. I've done the limit for this upper part of the contour. I'm currently doing the limit on this part of the contour. Yes, compute gamma of -1. Perfect. Yeah. Bam, 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 bam. Wake up. One does not simply bound a limit. Well, bounding the integrand as it goes. Or you bound the thing inside the limit. I think we're gonna, again, we can get rid of these cosines and sines. I guess we can't get rid of these cosines and sines. E to the US is a constant with respect to the limit. Your playlist not bad at all. It's been pretty good. Dominating chatters. Mm-hmm. It's the kind of streamer I am. What is S? S is going from 0 to I pi over 2. Yeah, this is it's Destin's playlist that we're listening to. So maybe we actually can bound these bad boys down here. We want the minimum because they're on the bottom, and we want to bound from above. So cosine, well, that's not good. We don't want to, 0 is a little bit too small. Never mind, we can't get rid of those. I'm tired of seeing them too, Desmond. I'm just stuck here. Good luck with your homework, though. Oh wait, sinh plus oh, this is 1, right? That's 1. Sinh plus cosh. Or is it? No, it's minus, isn't it? Is it minus or is it plus? It's minus. It is okay. If it's plus, it is e to the x. Oh wait, no, sorry, that's not squared. Oh, that's disappointing. Lonely. If you want, you can post your problem in chat or in my Discord. If you're posting an entire like homework assignment, I'm not going to just do your homework for you. But if you want, you can post like a problem. And then the unfortunate thing about today is that, or at least like me recently, is that I have a lot of work that I need to get done. So if it's a long problem, I just am not going to have time to do it today. But in general, if you have like math questions, I can like point you to a bunch of streamers who can, they're not, I don't, as far as I know, there's no one else streaming right now, but in general, like there's more people than just me who do like math help. Find the quartile? Okay. Grade 12 thing? Oh, nice, nice. So do we still want to use this identity? I feel like we can maybe get some cancellations if we play around with identities enough. cos squared minus sin squared. Because if I make like this sine squared into cosine squared, and that cos squared into sin squared, maybe something magical happens. The numerator... Oh, wait. The numerator's going to stay as it is. Is that a different identity? I feel like there is a different identity for cos squared plus sin squared. Maybe it's just nothing. But yeah, feel free to post it in like math discussion or homework help. Either of those channels would work. Altera92, thank you for the follow. Oh, looks like something popped up. Okay. Before I forget, by the way, since I see that you were a first-time chatter, the people there are more math streamers than just me out there. Found the midpoints and culminate frequency. Okay. So this is a list of math streamers that I like generally recommend. There's more than even like just this list. But like the people in the first part of the list all like offer themselves up as doing like math help. So if I'm ever not around, there's like a lot more people than just me who do this. You found the midpoints and culminate frequency. Oh, cool. Yeah, actual education is awesome. Use midpoints to calculate the median. Okay. So yeah, I believe for that it's been since I've done this, but I mean, just like we basically count this as we have 5,500 8 times, 6,500 11 times, 7,500 8,500, and so on. This is something that a calculator could definitely do for you. I assume you have to do this by hand though, maybe. This isn't that bad to do by hand. We do need to figure out like what these all sum up to. What is that? 19. Sum the frequency? Yeah, I think so. That's 19. 19 plus 35 is 54. Oh, Excel sheet. Okay, yeah. So I would definitely just like do an equal to sum of like all these cells. Okay, so since you said you have an Excel sheet, I'm going to assume you're allowed to like use the functions like that, and I'm going to bust out a calculator. By calculator, I mean Wolfram Alpha, at least to do this addition part. Because I'm going to make a mistake if I do it by hand. Eight, 11, 35, 29, 12, 6, 2. Okay. Okay, so 103. That's how many data points we have. The reason that's important is that when we're given frequency data like this, it's important to remember what that actually means. So we're just kind of assuming that things are in the midpoint. So if we have in the first one frequency of 8 for that row, it means our data basically looks like 5,500, 5,500, ... like 8 times. And then the data goes on to be 6,500 11 times. and so on like that. So like that's what frequency data actually means. And so if we want the median, Q2, that's the halfway point through the data. And so if we have 103 total points, the halfway point is going to be 103 divided by 2, sorry, which is going to be 51 and a half. Yes. 103 plus. Okay, yeah, so that's one way that you can fix it, because obviously, like, the half thing, it doesn't make sense. Sorry, I shouldn't say the word obvious. And so there's many different ways that you can deal with this. It sounds like in your class you add 1 and divide by, or you divide by 2 or multiply by 0.5. If you divide by 0.5, that'll get you the wrong answer, but I think I know what you mean. So that means we're going to get, it's going to be 104 divided by 2, which is 52. Data management here? Okay. Vossen, your integral 2u squared. Oh, yeah, I forget how you deal with that. Yeah, it's a weird one. Can I do your PD8 homework question once I've done my own, maybe? Okay, so we want the 52nd data point. So now we basically need to go back through the data and sum our way through until we hit 52 or above it. So this is 19 data points because 8 plus 11 is 19. 19 plus 35. We already said that's 54. Okay, so 54 is more than 52. So we know that Q2 happens in this range here. So I'd say the answer for this one is going to be 7,500. And so the 0.5 ended up not even mattering because it's 7,500 on either side anyway. That's basically how you figure this out. And so for Q1, that's the quarter of the way through the data. So it's basically the same thing, but we divide by 4 now instead of 2, because that's, or you can multiply by 0.25 if that suits you better. Either way, your answer is going to be 26. Yeah. And so we go, and now we go back through the data again and look for 26. So 19, 54. Oh, look at that. 7,500 again. But that's okay. It's just like, that's just what we get. AI is giving exact numbers. I guess I'm not sure what you mean with the exact numbers bit. Like, is AI not understanding the midpoint thing for these? Do you think solving HS exercises affects your learning? It can. If it's because there's still like fundamental things in math that I'm not that comfortable with, and so getting more practice with that does help me. For things that I've done like a million times, not really, but things I haven't done as much, yeah. It's like saying, oh, yeah, I wouldn't trust what ChatGPT is doing then. It's doing some weird. It's not doing the midpoint thing. It's trying to guess. Because like 52 is towards the end of this interval here because it ends at 54. So it's taking a number really close to 8,000 to try and kind of guess. But that's just not what your assignment is. So yeah, ChatGPT is just confused. We're supposed to use midpoints, so let's just use 7,500. If it was 55, yeah, it would be 8,500. You're right. Oh, nice Fembox, yeah. And so I see on the bottom there, just the last thing is to calculate Q3. For that, we can multiply by 0.75. That's going to be 26 times 3. 78? Yeah. And so now we'll get a different answer. 54 plus 29. Ugh. 63. 83? Okay, yeah. I think it's 83. So that means we hit 83 here in the next section, and we only needed 78. So Q3 is going to be 8,500. So yeah, only I hope that helps. Let me know if you have any other questions. I'm curious to see what Collar Cone's thing is. Oh my god, what the hell is this? Yeah, this is simple. You know, dude, just solve it. You know, it's actually too simple for me. I'm kind of bored by this question, so I'm gonna choose not to solve it, but I definitely could. I have no clue what like half these words mean. Good luck to you though. Too easy. I should mark Lonely Me's question as answered. Do I first solve exercise where you have to have a lot of background, something you have to do 5 pages of computation? I would prefer the lots of background, because at least that means I'm learning something. 5 pages of computation just is never a helpful thing, usually. Like, maybe doing it once is worth it, but the math that I'm doing right now is not at all helpful to my understanding of the thing they're testing us on. Like solving a PD that depends on a parameter t. The idea is that you can find a family solution that depends smoothly on that parameter. Oh. Interesting, okay. The homework you posted is more doable. I'll be the judge of that. Let a of r comma r. Okay, that's just an annulus, right? Yeah, it is. Okay. Conformally equivalent. Oh, yeah. Okay, yeah, you're right. That is more doable. Yeah, PhD. If I didn't have points depending on this problem, I would not be doing it. I don't know how you would do that problem, but that one actually does feel like I could figure out how if I Googled enough things. Okay. We're gonna leave. No, we're not gonna leave that denominator alone. We're gonna mess with it. So cosh squared is the same thing as 1 plus sinh squared. Sine squared is the same thing as 1 minus cosine squared. I'm hoping that we can cancel something with that sine squared, cosine squared, sinh squared, cosine squared. I think I'm going to make this worse by doing this, now that I look at it. What am I doing with that? Wait, that looks like I can get a double angle out of that. Oh, Wolfram Alpha does a number line. That's cute. I didn't even see this when I did this addition in Wolfram Alpha. It draws it on the number line. I like that. By normalizing, there you go. Oh yeah, okay. It's cosh 2x. That's probably worth using. Not x. As grad students, we are luckier than Zach or Penn. Why is that? With yeah. Well, I mean, Zach only just did his PhD. Wolfram Alpha isn't that new. I had Wolfram Alpha when I was in college, like the first time around. And Desmos. Penn, no. He did his grad school a long time ago. Well, I don't know how long ago, but like definitely not like recently. Penn right now is like the chair of a math department at a community college. Yeah. I don't mean to call him old. I don't remember how old he is. Penn good high. There you go. Okay, so we have a plus sinh squared cosine squared and a minus sinh squared cosine squared. So I'm going to cancel those two. Sinh squared r. Okay, that's what we're getting. Might apply for FAFSA. Oh yeah, I don't like FAFSA can never hurt you. Like you may as well apply and see what you get, because you never have to like take their offer. If I moved to Canada, Penn would give me tenure at his college. Maybe. Yeah, exactly. It's free. Okay, what is sinh? Well, yeah. Sinh squared can be written as cosh 2x. Do I want to do that? Let's It's also an applications depends college will run the whole department. Yeah. Oh, you know, we can bound it again. Okay. I know the way forward here. Because this bad boy, the minimum that term can be is 0 when cosine squared is 1. We'll have a real Twitch math department. Yeah. That's true. Okay, now we go to exponentials. This should go to 0. Because this u is saving the limit. Oh yeah, I'll check what the answer is, but we'll see if Dessen... Well, Dessen might be doing his homework. If he doesn't say it, then I'll say it. Wait. That's a plus for Kosh. Oop, song's over. I'll say it. The song is Show Me How by Men I Trust. I wasn't sure if you knew the song and were just like quizzing Dessen, or if you actually like wanted to know. That's why I didn't say it immediately. Oh, but I was just asking what the last song was. E to the R -1. You know all this? Okay, yeah. You seem like, and you were naming all the artists for the music that I was playing at the start. Oh, yeah, Destin dropped the link just in chat before. I don't know. Do I still have it? Oh, it's not gonna be my copy paste. Can I get it again? Yeah, I can. Wait, so did I have a Kosh? No, I had Kosh times cinch. Never mind. It's okay. I was wondering why I wasn't getting a cancellation of the ones. I think I'm just not supposed to. Plus e to the -2r -2. Does that make sense? If we have cinch squared, that's the same thing as Kosh 2x -1/2. Maybe? Yeah, I think I got the same thing as that. Okay. Can I just say this limit goes to 0 because it does? goes to 0. I'm not doing the limit again. The remainder of the limit is an exercise for the grader. Don will go with the engineers. I will go with the algebraic students. Color go with the geometers. Zach will make calc students pro with integrals. Ren will teach the measure theory. Addition color. Pure students for Putnam. There we go. Sure, Desson. Oh, yeah, that's true. Penn actually does do. I forget what the name of the competition is, but he's like helped like I think grade for a competition or something like that. I think for high school students. Oh, and he's done a bunch of competition integrals too. Back when he did that 100 integrals like series of streams. Okay, I really don't want to do this. But let's at least look at C3 and let's take that integral far enough that we can say it's the same thing as C1. Dude, this is going to be so much work to LaTeX this up. I don't know. I'm going to have to... Like I said, I'm not going to be possible to show every step here without having a 20-page homework. Although if I did make it a 20-page homework, that could be my revenge for having this problem be so long. I guess I'm really just making the TA suffer though. Okay, so on C3, Z is equal to minus R plus IS. DZ is equal to IDS. Okay, so we get... Oh, wait. I did make a slight mistake. It doesn't matter. I forgot to think about this I when doing the substitution in this thing. DZ is equal to IDS. There is an I out front here. Again, it doesn't matter because it's going to 0, but it should be complete. Submitting 70-page solution to color geometry. First homework. Teacher said that second homework is optional, will not be graded. That means that you won. Let's see what Desson posted. Either you do it or you don't. Inspirational quote. Wait, 7 pages? It's like you have a non-linear system of ODEs. It seems like that's gonna be a pain. Prove analyticity on a finite interval. That is nice handwriting. It's a good call. This is a good song. Oh, you use Taylor series. Oh, yeah, that's gonna make this take a long time. Probably need to though. Oh, is this like a series convolution? What the hell? Oh no, that's just a regular product. Maybe. Never mind. I thought there's some different type of convolution for series. Dude, why is it already getting? I guess my blinds are closed, but it is convolution. Okay, it's only 420. Blaze it, but it's getting pretty dark already. So we still have a month to go until the solstice. Also, it is. Craigasm indeed. I've got a delta function. Oh, and that's not like Dirac delta. That's a different delta. This is a lot of work. I'm not even halfway through yet. 447? Jeez. Yeah, I'm just like, I'm not even sure trying to follow it anymore. Only 2 students solved it? Well, you were one of them then, right? That's something that's kind of cool. Damn. You didn't? Oh, okay. Not on paper? Okay. 425? I believe it. It seems like the sun's already down. Why like we're on the coast. Why is it earlier than yours? Maybe it's the latitude. Wait, what's the difference in latitude between like New York and Washington? Um, I must be higher up in latitude, right? If it's earlier. How do you do this? Is it this one? No, 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 not that one. I don't know how you like. There should be a way to get coordinates on this. I don't know. I don't know how this thing works. Right click? Oh, hey. Okay. Which one is latitude? Which one is longitude? Seattle's like right around there. I don't know which one is which. Oh, you just okay. Anyway, versus like just middle of New York. That's a okay, yeah. No, wait. I assume the first one is latitude. Yeah. It's like nearly 47. Oh wait. Or like yeah, 47-ish versus just guessing the middle of New York, 43. That makes sense. Oh, partial fractions. Partial fractions is unlucky because it's really annoying, but you actually do kind of need it. It's good to know. Yeah, there's like a weird like maps that are flat like this are really deceiving. Like the northernmost point in the US, I think, is in Montana. It's not in Maine, like you would, like I thought. Wrong? Okay, but not Alaska. Not Alaska. The contiguous United States. Is that where you're going with this, Jed? Yeah, okay. Where will our future math department be located at? Penn's like west coast of Canada. I think he said specifically where exactly he is, but I don't want to like repeat it in case that's not a cool thing to say. How many connected components does the US have? Uh, is that a math term, connected component? Is this like a meme? Only 40K to Don to pay off debt? I would take that. I'm not 40K in debt, but I've got a lot of student debt still. The leftovers will go to a good cause, meaning my wallet. But I guess if you guys seen that, like, seriously, color code, there's like the 48 contiguous United States, and there's Alaska and Hawaii that are like separate. And then we can also get into like territories like Puerto Rico and all those things. That is a good cause. Thank you. I'm thinking about setting up a charity. My capital R's look like K's because I get lazy with drawing them. What's my social goal in life? I I don't know. I never thought about that. Maybe I'll have a small goal and just like be able to strike up a conversation with a stranger. Because right now I definitely can't do that. What's my SoCal goal in life? Probably not to go there more than I have to. SoCal is cool. It's just way too hot. After shopping again, why is there never any food around here? That's all I've been grocery shopping like maybe 2 or 3 times a week, and I haven't actually minded that because like food goes bad so quick. I'd rather just grocery shop more often than less often, but it's still like kind of a lot. Don't talk to strangers. That's how you get kidnapped. True, Skirtle. I did actually. I didn't talk to him. He talked to me, but there's like a. I went to a well-known like burger chain in Seattle, and we're like sitting at the cash registers, like just waiting for our orders, and he was like, "Oh yeah, that you don't know what it's like to live 100 miles away from this place." Because I guess it was funny because I actually do know what it's like because I only just moved here in the first place, but I didn't mention that. But I don't know where I was going with that story. So it was gonna be a banger though. That's kind of the entire story. Grocery shopping is dangerous for you? Why is that? It's looking at deferred plans for the school I'm hoping to get in. I can do 100 to 400 payments. Yeah. Wait, you can do 400 separate payments? Oh, for like a loan. Hope to like it, I thought that was like a like not a loan. You're just making 400 separate payments for tuition or something. That sounded like a lot. Someone was paying 100 a week. Oh, that's for the amount. Okay. Yeah, my student loans from undergrad, they're on pause right now because I'm a student again, but they're like they're like 300 something bucks a month. What do you think is a clear sign someone aged less than 5 will be good at math? I haven't worked with many kids. Probably if they show curiosity towards like how things work, I guess. I definitely asked my mom a lot of like questions about like space and stuff and she knows like very little about space. She's a social worker, but I've been curious about that sort of stuff from a young age. Gotta pay my current school's debt though, 6K. Oh, fair. 3-month payments through which could be like $200 $400. Okay. Great story. Thank you, Ren. I worked hard on that one. You buy too much. Oh, that's what you mean. Yeah. Grocery shopping hungry is never a good idea. You don't buy enough because every time I look in the fridge, it's empty again. I don't want to buy too much because like it just goes bad before I can eat it. I think we're in the Spanish language section of the playlist now. I don't mind. I think the last few songs have been Spanish, so I only just like kind of just noticed it. It's important the way they ask questions, more importantly whether they have a kind heart. That's fair. I mean, I don't think having a kind heart is necessary to be good at math, though. Looking at a lot of mathematicians, it's only because I make Jake jealous with the snacks. I don't even like them. that you know that sounds like it's worth the money though. Make someone else jealous. Use why we're gonna eat for the day. Wow, just straight up coffee. You're gonna drink coffee at like 7:30 at night, Fembox? Oh my god. Oh wait, no, maybe you mean coffee in general, not like right now. Squirtle, I am an expert Spanish speaker, and I will not have you doubt my amazing Spanish speaking abilities. You dedicated the song to my ex? Oh, I don't know what it's talking about. Pequeña doctora. Small doctor? Shouldn't it be doctora pequeña? Round of creamer, so I made it with milk. 1 spoon of sugar. That's not bad either. Speak Spanish. Show us your Spanish. Tell us your Spanish. She was a med student. Oh, nice. I've got to find something to say in Spanish. Okay. I know what I can do. Calculate the Spanish. I have a Spanish language math textbook that Andrew sent me ages ago. I can read something from that. You guys can be in awe of my flawless pronunciation. Where is it? You're not gonna drink this night. Just need to buy more if you're running low. Okay, okay. Yeah, Skirtle. If you, I have no idea how Tagalog works. If you want to send me something, I'll make you regret it. Yeah, Andrew's the person who sent me this book. Okay. Let's read a sentence or two. It's gonna be even worse because there's math words in this that are gonna be hard to pronounce. But let's do it. El análisis complejo es el estudio de las funciones holomorfas, que son las funciones derivables en sentido complejo o equivalente las funciones que vistas como funciones de variable real son diferenciables y satisfacen las llamadas ecuaciones de Cauchy-Riemann. Fue Cauchy quien descubrió las ecuaciones de Cauchy-Riemann, pero fue Riemann quien comprendió su importancia. Discord DM, read it. All right, let's see. Read. Okay. I hope this isn't something. Now you wouldn't make me say something that's like not okay. That's okay. Well, let me get the actual text on screen so people can see what I'm saying. I have no idea how it's supposed to sound. It's a rap verse from a meme song? Okay. I've only heard you speak it like whenever you forget to mute in Discord. Actually, I've heard it. I mean, I've heard it in person a long time ago too, but ang pawas koi tu matak tak sabilis me puma palak pak abutan natin ang lange ibuka ang pak pak Lengapen ang halimuyak in mega bulaklak. I think I cast a spell. You spilled tea. You spewed tea on it. There you go. Because it was so perfect, right? It's Tagalog, Dessen. Like Philippines. Izde utsne. Oh, that's I think that's funny that it probably deserves Izde not utsne. I don't know how it's pronounced, to be honest. I've heard people say Tagalog and I've heard people say Tagala, or I think I don't know how it's supposed to be pronounced, but the language that they speak in the Philippines. That's what Skirtle sent me. This is the longest non-scientific word in Spanish. Otorrinolaryngology. That still looks like a scientific word because of the ologia. Otorrinolaryngology. Dude, that's so hard to say. Otorrinolaryngologia. Ear, nose, throat? Oh yeah, that does look like ear, nose, throat. Sending the clip to Rome? Oh yeah, good. So he can also be in awe of my perfect pronunciation. They're called otorhinolaryngologists in English, I think. Oh. Interesting. Hey, Kate, Diamond. Sorry, I'm sorry I couldn't help you out with that problem. You know, let me actually show it on stream now that you remind me of it. If anyone would like to hop on the... This is... Haddock Diamond posted this question in my Discord server, and I was trying to do it, and I couldn't really figure it out. So if anyone wants to be a good Samaritan and help out Chaotic Diamond with this question, this is posted in math discussion in my server. Otorhinolaryngologist. Okay. What about hippopotomonstrosicipedaliophobia? The fear of something? Fear of long words. Oh no. Me speaking Tagalog's not a good reference. People barely understand me. um, yeah, a place I used to work, we often had people who didn't speak English come in, and um, so I have heard like I've heard it spoken back in like California, to be fair, but that was a long time ago. Are the forces correctly drawn out? I have a hard time even telling you that. Yeah, the exact problem once, Vossen. If you remember anything about how to solve it, it'd be helpful. No pressure. So, um, Chaotic Diamond said that the answer is supposed to be 0.66. But I think the answer that Chaotic Diamond got is 0.82. And the question is why? Or like, what went wrong? You feel the flatter against a vertical? Yeah, the slanted wall was really messing with me. I didn't know how you deal with that. You know? Okay. You put the blank problem? Okay. You have the famous anti-constitution element? I assume that's supposed to be pronounced in a French way, but um, I don't understand why this question exists. Everyone knows you need someone sitting on the bottom rung to keep the ladder stable who relies on the friction coefficient anyway. That's kind of true, Jed, especially when the ladder is at this much of an angle. That was pretty good pronunciation. Really? Okay. I wasn't even trying to put any like French mustard on it. like Dijon mustard, I guess. So F friction bottom ladder and F friction top ladder. You're missing the top one. It's frictionless at the top. Yeah, as Sunlock said. I assume so, Jed. Yeah. I was just like laughing because I was gonna say like put mustard on it as in like hamming it up, but then like I would ham it up in a French way, so I went with French mustard. And then I realized that, oh, French mustard, that's just Dijon mustard, right? Can I do a fake French accent? Oui, baguette. Um, Viva la France. I don't know. Quote. Oh, true. Yeah, Monty Python. That's harder though, because he was. Hmm. Yo, he was like yelling at the same time too. Your mother was a hamster. I know. I'm not saying with a French accent. I can't do it. I feel like when I was a kid, I was pretty good at accents, and at some point, I stopped practicing them, and I became bad. That'd be weird to hear you with an American accent, color code. I'm so used to your accent as it is right now. Remember the Spanish Monty Python? I don't remember that. Can it? Can I? Can I do an English accent in it, Governor? Would you like some beans and toast? Could I have some tuna? Bottle of water? I don't know. I'm mostly just stalling for time here while I hope someone else figures out the mistake here. Because this is such a confusing problem to me. Guy said in it he's English. Mm-hmm. It's the test. You know, Jed? Yes, I can. Now, the true streamer thing would be to be like, okay, guys, for just 5 gift subs, I'll dance like a monkey. And that's a joke. I'm not going to dance like a monkey. Guys, whatever goes wrong, you know what to do. Do an English accent. Okay, I'll try to remember that. A banana? That's pretty tempting. Now you're speaking my monkey language. I gotta do it now. Frictional surface inclined at 60 degrees. Because I was even trying to figure out. Oh, okay, maybe I understand where this equation is coming from. Like, I couldn't figure out what the 1/2 x was or what the 3/4 x was, but I think I just realized that, like, this is x here. Or, sorry, I guess this entire thing is, or the distance, like, here, up to the ladders, that, like, that's x. Yeah, distance from the pivot, okay. Or, I guess, maybe it's that distance then, diagonally. That makes more sense. So... Oh, like, a southern accent? Like, you mean, like... Yeah, like, southern accents are... If they get... In certain parts of the South, they're hard even for me to understand. It gets really... So southern accents can get kind of crazy, depending on what part of the South you're in. Cowboy style like movies? That makes sense. Oh, okay. So this is going... I assume this is... The 245 is probably... 25 times 9.8. And somewhere 637 is 65 times 9.8. Okay, so I understand where this equation comes from now. So what's the R of x? That must be the friction force. The answer should be 0.66. Okay, so this first equation seems reasonable. Oh, the reaction force at the top. Oh. Oh, so that's R times X. Don't we need a friction force in here, though? Like, why isn't there a plus FF? When I played Red Dead Redemption 2, I needed a good 30 minutes to acclimate my ears to hearing that cowboy's accent. Yeah, I can imagine that'd be hard to understand. Kid, I used to get these problems and I didn't like this anymore. I've never liked this type of problem. It's just there's too much going on for me. I'm trying though. I'm taking the pivot at the bottom so the friction is 0 distance away from the pivot. Oh, interesting. I haven't solved the problem, like... I don't know if I've ever used pivots before. I guess I don't know how they exactly work. I think this essentially is it, but it's slightly different from the sum of f sub x, Vossen. Yeah, torque, okay. Yeah, the issue is I hardly know about torque. That's why I'm having such a hard time with this. The South French accent is very funny. I wonder if I'd even hear the difference. Something was about any point to zero. I assume that's what this is here. I wouldn't know what to do that for myself. Sum of torques equals 0. Okay, I don't know if I've even ever solved a problem like that before. But you get 460 for R. You get the X component. Oh, interesting. Hey, TV Josh. Well, it says 3. It's really small, but that is 3/4. It might be hard to read on stream though. There's a 3 up there though. Oh. Oh. Okay, I think I have a hard time verifying the first equation, but like this seems pretty reasonable. What you've done here. No worries. So forces in the y direction. Huh. Okay, so we need to have a smaller number. So either the numerator should be smaller or the denominator should be bigger. If it rotates counterclockwise, it's positive, other way is negative. I see. So like if that's your pivot, these two forces here are trying to rotate you clockwise, so that's why they're negative. Whereas the reaction force is going the other way, so it's positive. Okay. Okay, at least I understand what you're doing now. I don't understand why it's wrong. Um, so yeah, that's a 20-degree angle. That's good. That's 40 because it's alternate with that angle. Which means that must be 30, right? Huh. Yeah, I'm really not sure about this. Let me see what color chrome linked. Yeah, maybe. I don't know if you already tried this, but like I'm kind of getting like the best. Like I'm kind of just about to Google and see if I can find someone who solved the question. This is a South French accent. Sounds like normal French to me. The people next to him, they always look uncomfortable. Look at his face. Look at his face. I don't know. Maybe that's just how French people look. But they don't look comfortable with what he's doing. Okay. Let's see. Chegg. Like a combination of those two guys. That's a crazy one. This looks like a similar problem. You have an answer? Okay, if it's 0.66, then you did something good. I don't want to watch a 12-minute video. This looks like basically the same problem, but with different numbers. Of course, there's another YouTube video, though. It's 16 minutes. Ugh. This one has the wall at a 30-degree angle. I'd rather have it written out. I don't want to have to watch a 16-minute video. Oh, yeah, sure. It's posted in the Discord too, but that's the work at the bottom there. You found it? Usually Chegg is paywalled. 0.05, oh, this one isn't paywalled. His torque for R is not correct. Really? It's not RX? I don't know why it wouldn't be. Yeah, you're right, Chaotic Diamond. I also see it. R is not perpendicular to the ladder. Oh, it's perpendicular. Oh. It's perpendicular to the surface, not to the ladder. Wow, that's so tricky. Yeah, it's a 70-degree angle. Yeah, how do we get that new angle? We want that. Is it 90 minus 40 minus 30? Or no? Yes? R is 70 degrees from the ladder. I don't know why I'm getting so lost in the trig right now. I want to just slap a cosine of 70 on it. Would that get the right answer? Sine? Okay. The reaction is perpendicular to the wall. Because the wall is exerting the force, right? So it should be 460 divided by sine of 70. Let's see if that fixes the answer. $489. And then we multiply it by cosine 30. To get 423. And then we divide by 44.6. Oh, what? Now you get 0.66? Okay, yeah, so the y component must be off also. Or, yeah. Maybe that's a sine of 30. If I change it to sine of 30, does that fix it? Nope. I'm solving it by guessing and checking now. Uh... Yeah, or are you able to spot which numbers? Oh, you did? Okay. Nice, thank you. God, what a crazy problem. Yeah, I'm just trying to figure out where that tangent is coming from. Oh, okay, yeah, that's the height of the ladder above the ground. Just because we have a 40-degree angle there, we know the bottom is, as Femlox is calling it, 4L. You use just like L. But this is basically the same thing. So that, like, Femlox's 4L is your X, and then tan 40 just gets the vertical height. Yeah, that does avoid fractions. That's the nice thing about that. Y equals mx, true. And so I guess 25g times 2L. Yeah, this is where we sum up all the torques. This is pretty good handwriting. I can't judge. Okay, yeah, dude. If you understand this chaotic diamond, I'll leave it here. I would need to like look at it for a lot longer before I understand it. This is a really difficult problem. Good luck with your test on Monday, by the way. Should be enough. All right, sounds good. All the L's cancel and the G's cancel later. Okay. Thank you, Fembox and also Ren for the help. I think there's still something wrong even after we fixed the R times X. I'm not sure what it will be though. That doesn't need bread? What doesn't need bread? I'm glad you do, Fembox, because that way I get to just stall while you solve it. It's a French expression. The aftermath is not that bad. Oh. Interesting. I feel like French would have a lot of expressions involving bread. Okay, is this similar enough to the previous integral that I can just cite it? It is, because we're going to take the magnitude of all this stuff and the minus signs will go away. Okay. Oof. If you're rich, you hunger for money. If you're broke, you hunger for bread. True. Now we get to do the exciting part of the integral. We get to actually get the part that we want. We've proven all these top bits go to 0, finally. So that means this integral here is equal to the integral around this contour. And the integral on this contour, we're taking the principal value because it's going to go through its singularity. Which actually, we need to write principal value already here. The exponent looks like it's in the fraction. Not stung by cockchafers? I should use some French expression in English to confuse people. What? What would that possibly mean? That means of great quality. Because the cockchafers haven't gotten to it? Okay. Papik de anetones? Um, so because it doesn't enclose any singularity, it approaches one singularity, and when you approach a singularity, you only get half of a residue. So it's going to be pi I times the residue, not 2 pi I. Cosh of 0 is 1. Sinh of 0. Oh, come on. You can't do this to me. There shouldn't be 0 residue, should it? No, it shouldn't be 0 residue. That would make no sense. Is it not a simple poll? I don't like thinking. In France, they also have this weird idea to translate English movie titles into French to have to translate them back to English. That does sound weird. I hope you get some really weirdly named movies. Hangover became a very bad trip. Is Ren still here? Maybe. Paging Ren. That you'd be able to do this problem in a cinch. FizzBuzz, I've been working on this problem for most of the 3 hours and 20 minutes of this stream, plus a few hours last night. It's so long. Oh, thank you, Ren. Oh, Diamond? Well, yeah, Diamond is here. About to hit up this year-old aged eggnog? Oh, you mentioned that you make that, right? Actually, yeah, you made that, right? I don't know how you, I forget if we talked about this, but like I don't know how you age eggnog. Like, wouldn't it just spoil? um why am I getting 0 for the sum for the residue? This is terrible. Am I falling in the apples? I definitely am. It's exactly what I'm doing right now. Uh, the residue of this at 0. I've gone through a whole lot of trouble to make a box contour, and I've proven that the sides and the top of the box all go to 0 in the limit. It is removable, right? Uh, I was thinking about that, but I realized that if it is removable, I guess what does that mean? Is it supposed to be 0? If it's like I shouldn't be like I don't know. Like the answer definitely isn't 0, so I need to be getting not 0 from something, but it's much a nice way to solve that ladder problem. I just realized you can sum the moments about a point in space that both the normal force and the ladder go through. Just a bit of geometry to locate that point. Really? That's interesting. I didn't realize you could put the moment just like out in space randomly like that. Yeah, that's right. Good song. Let's see. A List of Reasons Why I Miss Your Face by Ariel Days. A list of reasons why I miss your face by Ariel. Noted? Okay. I'm going to finish typing it, but we do need more Fizzbuzz streams in our life. Did I say hi to you, Denali Dice? I saw you type something. I don't know if I responded to it. I'm sorry if I didn't. You'll need good reading material in approximately 15 minutes? Is that a poop joke? So yeah, I'm trying to take the, like, where this came from is I'm trying to take the inverse Fourier transform. Actually, I could give that to Wolfram Alpha and see what it spits out. The thing is, it's really important that U is bounded between 0 and 1. I don't know if Wolfram Alpha is going to figure that out on its own. Am I giving my tongue to the cat? Definitely. But that one might be an expression in English too. Like, if someone is speechless, you might ask them if a cat got their tongue. Those are reasons why I miss Fizzbuzz streams in my face. Let's see if Wolfram Alpha can figure out this inverse Fourier transform. It means giving up in French. Oh, that's different then. I'd never know how to use that thing. Let me do this instead. Okay, so if I just give it cinch of a k, initial variable k, is it going to know what to do with a? Oh, sorry, I'm wrong. I'm bad. I'm hoping it tells me it gets a solution for a between 0 and 1. It doesn't get any solution. Damn it, Wolfram. Solve the problem for me. How hard is the math I'm doing right now? I mean, hard is relative. For me, this problem is very hard. So this comes from I'm currently working on a master's in math, applied math, and the homework this class is from is from me going crazy and deciding to take the PhD level applied complex analysis course. This is grad school math. You would learn it if you did grad school in math or in physics, probably. You wouldn't normally learn this in undergrad, I don't think. The full context of this problem is that it is the solution to a partial differential equation basically imagine you have a small circle being kept at 0 degrees Celsius and a much larger circle where like just the border is kept at 100 degrees Celsius. And the PDE, if you solve it, will tell you what the temperature is in the space between those two circles. That this is a weird domain to solve on, so we actually can find a coordinate transformation that kind of takes this region and unwraps it into just like a vertical strip. And as it turns out, by some miracle, that doesn't change the nature of the differential equation either. So you can just solve it in this simpler domain and then take the coordinate transformation back the other way. But yeah, so this normalizing stuff that you would do, you might get introduced to it in undergrad, but you wouldn't go deep into it. It's like I was like kind of barely introduced to partial differential equations at the very end of my undergrad. Do I have pure math PhD classmates? Not as far as I know, no. The pure math program here, I looked at it and it seems weirdly like there's only ever like 3 classes total just for like the core courses. I don't know when, if or when they take electives in just the regular math program. Complex variables is great. You math folks can keep your complex analysis. Is this with radiation? It might apply to something with radiation too. Like this equation is also helpful with like electrostatic potential. It has more applications than just temperature. I don't know if radiation, if it would apply to that. But yeah, that there's the partial differentiation. This partial differential equation is called Laplace's equation, and it applies to. I'm gonna probably say something wrong here. I think it applies to certain types of like vector fields when there isn't a source or when there isn't like a source. So like if this partial differential equation would hold if you're not in a region that contains a point charge, if you're doing electrostatic potential, something like that. Is this dark magic? Yes. Are you the person that makes equations on the fly? I can make equations on the fly if I just want to make up random crap. This problem could be deep in the sense that you can paste the strip at infinity and make a pointed space. Am I smoking like a firefighter? I wish I was smoking right now. Depending on the substance. Right. Yes. It is like the steady state result of the heat equation. That's true. Oh, thank you, Fizzbuzz. Well, okay, yeah. Pi sine L over pi over cosine L over pi plus cosh L over pi. Oops. Except in the exponent. Wait, there's an exponent? Where is there an exponent? In the input. Oh, okay. No worries. Okay, that's good to know what to expect here. Your problem is that you know how to solve the heat equation with some initial condition. The case function, in the case where the function vanished on the boundary, the Laplace equation helps you study the case where your function doesn't vanish on the boundary. Interesting. Times pi not divided by pi. Oh, ha, okay. That's the other direction of slash. Thank you. Ugh. Thank you for running that through Wolfram FizzBuzz. So now I know like what to expect for the right answer. I don't know how I'm gonna get there with what I have, but my shortcut in the ladder problem gives me the friction force between ladder and ground. Still have to do some faffing about to get the friction coefficient. Oh, okay. So I guess the issue is that if there isn't a residue at all, have I just drawn the wrong contour? That would be unfortunate. Like we talked about this in class, but I forget what the conclusion was. That like removable discontinuities are different. Do we need to expand the box to include the next singularity up? Okay, yeah, that's what you're saying, FizzBuzz. Um, if I really don't want to go through and redo these limits for the slightly higher contour, so I'm just gonna ignore that for now. Is there a type of math that uses formal logic? The answer I want to say immediately is just yes. I'm trying to think of I'm trying to name an actual like part of math. Um, like logic is always in the background of math, no matter what type of math that you're doing, in terms of like how you prove things or what counts as a proof. But I assume you mean something more directly related to logic. And I want to still say yes, but I don't. There's so many niches of math that I just don't know. I um Like, whatever the hell Gödel was doing, uh, I don't know what type of math that's called, but like that type of thing I would think is maybe more like what you're after. So you may or may not have heard of them, but there's these Gödel incompleteness theorems that say, at least in some, with some caveat or only in some type of context, you can never make a system of math that is complete and consistent. So you never know if you've proven everything, and you never know if you have some contradiction that you haven't noticed yet. And this is like a part of math that is kind of all about logic. I guess mathematical logic is the subfield that you might want. If you mean in a somewhat novel way, you can look at modal theory. Okay. The people that do logic, they're the true heroes. Oh, wait, model theory. That's... Oh, why did I read that as modal? Maybe because I still have Gödel on the brain. Okay, yeah. So mathematical logic, model theory look like good things to like look into if you're interested in this type of thing. Denali dice. Wait. Uh, Houston, we have a problem. Oh wait, no, it's still foot finite. That's the important part. Uh, yeah, we only care that it's finite, right? Because it like this coefficient specifically is between 0 and 1, and that changes the behavior of this. But it's still finite, and I think that's the important thing. Model theory is using algebraic geometry to prove some non-trivial fact. Okay. Um. So what's the residue of this thing at pi I? I'm still gonna assume it's a simple pole. It should be. Oh yeah, okay. The U saves us. Oh, thank God. Cosh of pi I is cosh of pi, which is -1. Whoa, what happened to this thing? What the hell? Did I... Is it that button? No? I think I hit that... Oh, what? Okay, cool. Fixed it. Does formal logic and epistemology ever converge? That's a good question. I would imagine they do. I don't know much about either, though. Kind of gonna have to hunt through Wikipedia to have anything to say. Hey, Adia. Seeing a course in type theory, they were explaining how you can use Artin techniques to glue topoi to build some interesting model. Okay. Time? 5:30 in the evening. Probably gonna have to go make dinner soon. Man, I thought I would actually finish this problem on stream. This is such an annoying problem. 7:05 in the morning, geez. It's really early. Okay, now what is epistemology? Do I know Java? It's been years since I've coded in it, but that is like, um, I would still say that I know it, yeah. I'm gonna be rusty on some of the syntax things. I would imagine that epistemologists need formal logic, at least at some point. Maybe not the other way around? I'm not sure though, like I would love to learn more about philosophy and this type of stuff, but I'm kind of uh not educated enough. The temperature? Oh well, my heater's on. Actually, I don't know. It's somewhere around 60 degrees Fahrenheit. So yeah, Denali dice. I'm not sure. I can't confidently answer your question. I would bet that they do. Where I think formal logic kind of forms the foundation for really anything that wants to be rigorous, not just epistemology. Like this like provides you the language you need to reason through statements. It's 59? Nice. So yeah, I don't know the honest. I wish I could speak a bit more confidently, but that's at least my guess at what the answer would be. Epistemology? Yeah. That's my true specialty there. Sounds oh god, Adia, yeah, please do get some sleep. Thanks for saying hi. Hey Art. Um It's everyone's specialty, that's true. We'd be pissing every couple hours, yeah. Yeah, I feel like I've maybe already seen you in his chat, but if you don't know Ivan Neo, I feel like he would have a better answer for you. I have a feeling you already know about him, but at some point I'd like to like get up to speed with philosophy and be able to like engage better with his streams. I haven't had time to do that yet though. Yeah, he has a really cool stream. I really like listening. Series and sequences. Oh, I'm sorry, Art. Those can be really tricky to learn. Um, so this isn't, so it, that's kind of weird. I don't have the denominator. I think I am getting the numerator though. Well, maybe this e to the v pi will somehow come out to be the same as the cosine plus cosh. A secret video? There's no secret videos, at least. I can, thank you for the meme raid. Pause on my notes has a section on series and sequences that I really like. And then I would bet 3 blue 1 brown has a video on these. Let's find out. Probably in his calculus. Only Taylor series. Yeah, I don't know of a good video for sequences in series in general. But Puzzle Line Notes is a great resource. Okay, let me catch up with Twitch chat. A equals integral in the first contour. You'll probably be able to write something like A. Sounds good, Art. Oh, maybe. I haven't seen Physics Impression in a while. Yeah, I haven't seen him around at least since like Halloween or so. He pretty often takes breaks from streaming though, so I'm sure he'll be back. And famished. Yeah, I was wondering if you were actually streaming because there's 3 people. But that was a meme raid. Either way, thank you. I'll take it. It's also a very interesting idea to study homotopy theory of topological space. You can build some kind of model. The idea is that infinity groupoids capture the homotopy type of topological space with the infinity groupoid hypothesis. Oh, okay, that sounds weird. Then the answer is kind of the form A equals residue 1 over 1 plus e to the I pi v, which is like the form of the answer. Oh, Fizzbuzz, please backseat away. Versus 2, now it's 3. You're building up an audience even if you're offline. Oh yeah, that might be it. Famished. Join for some chat and then raid. There we go. Yeah, Fizzbuzz, you are probably correct. That would be easier than doing all these limits and showing they go to 0. Ugh. I don't know if I have the willpower anymore without getting food to do this. This seems like the right track, though. I think you're making the right call there, Fizzbuzz. I need to revisit one of my integrals, and they won't be 0, but it will be the same thing as one of the initial integrals. Somebody clip me sinking in my chair. Need a Coke to push me through. The idea is if you can simplify e to the IV lambda plus 3i pi over 2. That makes sense. It should simplify because like It was simplifying pretty well when I was doing all this stuff. My work will still be helpful for the sides of the contour. I just need to adjust some of the numbers. Ooh, pluribus, yeah. Can't miss out on that. When I was doing it, I didn't really clean up that well. Maybe a change of variables could do it, though. Change of variables would be tricky. I'm going to copy down the things that you're saying right now, FizzBuzz, because I think I'm going to need to, like, take a mental break and get some food. But I think you have the right idea. This sounds right, at least. Oops. Kind of makes me feel better. You've been Stockholm syndrome into liking these problems. This is just... I really don't like this problem because this homework isn't even about Fourier transforms. This problem is about bilinear transforms, which I figured out hours ago. I figured it out yesterday, actually. I'm just stuck on this stupid part of doing the inverse Fourier transform, which we already went over weeks ago. Hey, Territar. New name? Slightly. Thank you, FizzBuzz, for the idea. Territar, you did unfortunately come here right as I'm gonna end the stream. It's been a long one. But I appreciate you saying hi. Hopefully the timing works out better next time. I would need to think a bit harder about what happens at 0 as well. I'm kind of concerned that just being finite isn't enough or something. Territar, they're sort of going. I've spent most of this 4 hours on this one inverse Fourier transform, and I'm only slightly closer to actually doing it than when I started. If I've been streaming... oh, it's Saturday. I thought it was Sunday. Yeah. Is Ivan about to end? He's probably going to end soon, so I should end my stream before he does. Have we done any presentations for class? For this class? No, that there are no presentations for this class. I'm going to end the YouTube stream here on Twitch. We'll right out to Ivan. Territar, thank you for being here. Anyone else who's here on YouTube, thank you for being here too. I'll be back at some point over the week.